Welcome to lesson 46. So we're going to talk about multivariate data or multiple linear regression this week. Last week we talked about bivariate data, so that was when we were looking at a quantitative response variable and a quantitative explanatory. This week we're going to look at a quantitative response variable and multiple explanatory variables. So we're going to introduce it, talk about how we visualize it, and then move on from there. So suppose, because the example that we were using in week 8, we were looking at high school GPA predicting first year college GPA. SAT scores might also be a predictor of first year college GPA. So can we have more than one explanatory variable? Absolutely. You want to be careful though, because on occasion they can be related to one another and you want to be careful there. So what we're looking at here is high school GPA, like how that works, but high school GPA plus the effective SAT scores might help explain what first year college GPA is. This is just one of many ways that you can work to identify or visualize what we're seeing in a data set. So absolutely, it's natural to assume our response variable might be related to more than just one explanatory variable. For example, if you're looking at the selling price of houses, you might think that the square footage is related to how much a house sells for, or acreage, and or number of bedrooms, and or number of bathrooms, and so on. There might be multiple factors that might be related to what the selling price is. So explanatory and response variables. So for explanatory, they may help or predict changes in the response. It does not necessarily mean causal. We don't want to necessarily say the explanatory causes, but knowing something that's happened in the explanatory variable might help explain something that's happened in the response. In this scenario, for week 9, your explanatory variables, they can be quantitative or categorical. Last week they were only quantitative. Back when we did that single factor ANOVA, they were only categorical. And so these are known as predictors. They are independent variables, or X values. The response variable, this is usually the variable we're interested in predicting. So if you're looking at house prices, it's going to be the selling price of the house versus factors that you might think might change what the selling price is, such as square footage or number of bedrooms. So one example, and I know this is very limited, I'm sorry, you might think, okay, well, minutes of activity in a day, so minutes of physical activity plus, biological sex, and just a caution, a lot of times stats is infamous for looking at just binary biological sex. They use it interchangeably with gender. Whether or not this is reality, this is a whole other issue. And knowing the minutes of activity, the biological sex, these might help us explain the body fat percentage. So visualizing, this can get complicated. We can use scatter plots, but sometimes it requires us to use scatter plots with either different colors or different shapes for the points or sizes. So it is absolutely trickier when there's more than just two variables to visualize. So for example here, we're looking at eBay starting price and total price of Mario Kart with an indicator. I believe it's a used or versus new. I would guess that, 0 is probably new. 1 is probably used. We'll double check later. That kind of idea. So they have it sectioned by color. So we have pink and we have blue, as well as we have the starting price and we have the total price. But here is another visual of the same data. So this is trying to put it into a 3D visual. And then here's another. So we put starting price, which is an explanatory, selling price, which is the response variable, we looked at the number of, we will get into this example, but the number of wheels contained. So that tells us how big the data point is. So here it's very small, which means 0 wheels were included. Here it's very large, which means 4 wheels were included. And then color indicates, was it used or not? It's actually just going to be 1 for yes, 0 for no. It's not going to be in between here. So as my scatter plot matrix, this is something that we use quite a lot, is we go ahead and we go plot the scatter plots for, usually we will put the response here, and then we'll have our various explanatory. So looking here, we can actually look at, just visually, what is the relationship between each variable with the other variables. So the response, ideally, it's going to go in this top row. So you want to see, for total price here, you want to see relationships here. If there is a linear relationship to view here, you want to see it in this first row when you're looking at the response variable. Versus the explanatory variables, so we have starting price, we have the number of wheels included in the set, and then whether or not the set was used. So here you don't want to see a big relationship. If you see some big noticeable relationship, that might indicate that the explanatory variables are related to each other. That's a whole other problem beyond the scope of this specific class. Just know that you don't want to see a relationship between the explanatory variables. You do want to see a relationship between the explanatory variables and the response variable. Because if you see a relationship between the explanatory variables and the response variable, that's a good indication that that explanatory variable helps explain something that's going on with the response. That starting price explains something that's going on with the total price. That number of wheels included explains something with the total price. That whether or not it's used might explain the total price. So for example, we went ahead, we took our college GPA, so our first year college GPA, and our high school GPA. We went ahead and plotted those, but then we went ahead, and for those 10 students, we also included their SAT score. I'm not sure what it's for, because usually those are what? Like written, English, and math. I'm not exactly sure which one that's supposed to be. So looking here, we want to say, based on this scatter plot matrix, which statement is true. So A says there's no relationship between high school GPA and college GPA. So looking here, I want to look at this plot, or this scatter plot. Looking here, it looks like there's actually a very, very linear relationship. I would argue that A is not true. B says SAT score is not related to either college GPA nor high school GPA. So it's saying look at this column or this row. Quite honestly, it doesn't matter which you look at. They're going to be very related to one another. So I'm going to focus here. I would argue SAT score, as SAT score goes up, the high school GPA seems to go up. I would probably argue even as the SAT score went up, the college GPA went up. So I would argue that this is not true, that SAT score is unrelated to high school GPA and it's unrelated to college GPA. Our third, given college GPA is the response, there's a positive relationship between the explanatory variables. So looking at college GPA as the response, do we have positive relationships? So here, I would argue college GPA and high school GPA have a positive relationship. That as high school GPA goes up, the college GPA goes up. Looking here, I would argue also a positive relationship. That as SAT score went up, college GPA went up. So I would argue the true thing here is that college GPA has a positive relationship with the other two variables. So keep in mind, whatever your response is, so college GPA here, you want it to have a relationship between the other variables. The explanatory variables, you don't want to see a relationship with. That is a whole other can of worms. That's a whole other set of problems. You don't want those things to be related to one another. You want them to explain the response, but not to be related to each other. It's a lot messier if you know that they're related to one another. And once again, I would argue, no, they absolutely are related to one another. That's a little iffy. So that leaves us off at lesson 47. We'll join you there.